So, what do you think on this very first sentence? Complete the sentence. A log is a way to write the inverse of what? Of an exponent, right? Of an exponential, right? A log is a way to write the inverse of an exponent. That's why they exist. All right, number 2. This was yesterday we talked about this. Or actually Monday. When we evaluate a log, what are we finding? The missing what? Exponent, you bet. When you're evaluating a log, you are finding the missing exponent. So anytime you're asked to evaluate or to simplify, that could be part of it. And then the last one, logarithms are what type of functions? Inverse functions, you bet. So remember, inverse functions are what we use when solving. You guys already know adding and subtracting are inverses, multiplying and dividing are inverses, squaring and square rooting are inverses, cubing and cube rooting are inverses. You have all these inverses already. Fractions and using the multiplicative inverse, right? Using the reciprocal. So now we have one for when x is in the exponent spot, right? So that's what logs are for. All right, so our very first property that we're going to talk about is related to exponents. Because these are inverses of exponents, any rule that applies to exponents also apply to logs. So what's nice about this is you already know the rules for exponents. You're very familiar with them. You've been working with them for years. So what's nice now is you already know the rules for logs. You just have to start practicing with them. So that first one, as you can see in your notes, is called the power property, right? So you have something called the power property. Power rule, sure. Sorry. Power property, power rule. And what the power property says, power rule says, is, well, it has you reflect back to what you know about exponents, right? So I know they use a and b on here, but if you have x to the 3rd power and we're raising that to the 7th power, what do you do to the 3 and the 7? You multiply them, right? You guys have known that for a long, long time. So when we're dealing with logs, we have to think about them as exponents. So this example here is log. The base this time we're calling a. And we have, just want to make sure I'm using the right letters that go up with your notes. X to the b power. Okay. So this is an exponent. This part right here is an exponent that's being raised to an exponent. You have to think of logs as exponents if this is going to make any sense at all. So what do you do when you're raising an exponent to an exponent? You multiply those exponents together, which is why what this property says you can do is take that b and move it down front and multiply it by log x base a. See, now we're multiplying an exponent times an exponent. That's what the property says you can do. Okay? That's the definition of the property that you see on your paper. But that's why it works. You're raising a power to a power. When we raise powers to powers, we multiply the exponents together. So we just simply bring the b exponent down front and we multiply those exponents together. So let's look at that first example. Number 1 says, and I know we just learned a property that could do this faster, right? Okay, but let's practice this using this new property. What do we have to do with that 4 according to this property? It comes down front, right? So this would be rewritten as 4 times log 2 base 2. Now, can you simplify or evaluate log 2 base 2? There's no x. Listen, we're looking, when we say evaluate, we're saying what's the exponent? So 2 is the base. 2 to what power is 2? 1. So So log 2 base 2 is just the number 1. Because 2 to the first power is equal to 2. So we can simplify that or evaluate that log. We don't need a calculator to do it. Now 4 times 1 is 4. You could have also used the property that we talked about yesterday, where the bases match up. Bases match up, it simplifies to just 4. So it's just another way to show that. This one just happens to have bases that match up, but they don't always have bases that match up. Make sense? All right, let's try number 2. Let's use this power property, this power rule. Where does the x go? Down front, right? So x times log 36 base 6. Okay, can we evaluate log 36 base 6? What does that equal? Just this part. I don't want the final answer. I just want you to evaluate log 36 base 6. 2. Okay, so that part is 2. Multiplying it by x. Now you can feel free to switch the order to 2x if you'd like. That's just kind of our standard notation. Make sense? See? All right, number 3. Oops. All right, what's the rule say we do? Let's bring the 3 down front. Can we simplify anything? Nope, nothing to simplify here. That's our final answer. These 3 problems are examples of what we would call expanding using this property. It would be called expanding because we're basically our answers don't have any exponents in them. Now the next 3, do you see the next 3 problems? It kind of looks like our answers, don't they? We're going to be using the reverse of that property. We're going to be putting the exponents back in and using them that way. All right? So let's try number 4. On number 4, we have 2 log 3 base 9. Okay? So where should the 2 go? It becomes the exponent to the 3. Good. Well, let's see. Can we do anything with this? What is 3 squared? 9. So now I have log 9 base 9. Oh, what's log 9 base 9? It is 1, isn't it? It's find the missing exponent. Here's a great example of when using this power property helps to make the problem much easier. Now we could have looked at the very beginning and said, okay, log 3 base 9, that's a square root, so that's 1/2. And then 2 times a half is 1. So we would have gotten the same answer. But let's be honest, there's a lot of people still not really getting that whole like 1/2 thing as far as square roots. Or you might make a mistake somewhere in that process with fraction work. This way, it takes all the guesswork out of it. 3 squared is 9. Log 9 base 9 is 1. Done deal. Make sense? Let's try number 5. All right, so where's the 1/2 go? Right, it's now the exponent. What does half power mean? Square root. So what is the square root of 16? Ah, so what's my final answer? 1. All right, try number 6. Well, you at least move the negative 2 where it belongs, right? All right. So what do powers that are negative do? It flips them, right? Makes them a fraction. All right. So that's 1 over 8 to the second power. What's 8 to the second power? Okay.
And what we do at that?
Well, let's find the exponent, right? Evaluate means find the missing exponent. Hopefully we all got here pretty easily, right? Log 1 over 64 base 2. Well, now we got to figure out what exponent would make 2 turn into 1 over 64. It's not a fraction for sure, because fractions mean roots. And that makes numbers even smaller, right? I don't want the number to become smaller. I want it to be a reciprocal, which means a negative number. And I want it to become, the 2 become a 64. So I need to figure out which power of 2 makes 2 turn into 64. And it's not an 8. So it is 6. Now remember when I said you need to memorize some powers of 2's? I tell you, you should know them up to the power of 5. You should know 2 squared is 4 and 2 cubed is 8. And then to the 4th power is 16 and to the 5th power is 32. That should just be automatic. Now from there you can just double it, because the bigger numbers don't show up quite as often as those other numbers. Well, 32 doubled to 64, so it's just 1 more past 5. So does it make sense that that would be negative 6? That would be the exponent. This is a perfect example of when this property does not make a problem any easier. Actually made the problem harder. This definitely made the problem harder. So here's the deal. You don't always have to use the property just because it's there. Because I look at that very first step and I'm like, man, do I really want to deal with 1 over 64 when I already know what log 8 base 2 is? What is log 8 base 2? What is log 8 base 2? What is this part? It's 3, isn't it? Isn't it just 3? Just plain old 3. So if I just did negative 2 times 3, I get negative 6 really fast, don't I? I don't have to think so much. But here's the deal. You have to know and realize when the route you're taking is maybe not the most efficient route. You know, if you start doing this, like, okay, I'm using the power property, and I'm 8 to the negative 2, and then you get 1 over 64, and you're like, man, that seems like a lot of work, right? And then maybe you go back and you look at that original problem, and you say, can I do this in a different way? And you look up there and you're like, wait, I know log 8 base 2 is 3. Can't I just do negative 2 times 3 and get an answer? And yeah, you can. There are several different ways in order to get your answers on these. So I'm just sharing with you, sometimes you can take a different route. You will get the same answer. Both of these ways are equally right, equally good. It's a personal preference, right? All right. So we're not making any judgments here. I'm just letting you know that you have options.